Hello everyone. Today is December 14 and I'm planning to open a new slot in our Coding Advent Calendar. Today's problem is about Grinch trying to steal presents. We need to create an efficient algorithm for Grinch so he can collect as many presents as possible without triggering an alarm system. Sounds interesting. Let's dive in. Here is a problem for today. House robber. But since it's like Christmas time, let's consider it Grinch. So you are a Grinch. You are a professional Grinch playing to rob houses along a street. Each house has a certain amount of money stashed, and only constraint stopping you from robbing each of them is that ancient houses have security system connected, and it will automatically contact the police if two ancient houses were broken into the same night. Given an integer array nums representing the amount of money for each house, return the maximum amount of money you can rob tonight without alerting the police. So here are two examples and here are results. How are we going to solve this problem? So it is clear that we have two variants for each concrete case. We can rob this house and take money from it, or we can skip it and be able to take money from the next one. In the next one, we can also rob it or skip it. So it looks like binary recursion, but even with memorization, it will be not optimal. And I would like to offer you to think about this problem in a little bit different way. So imagine we have this array 3, 5, 1, 1, 3, 3, 1, and so on. We don't know how many we have. Next. And we have two cases. We have case 1 and we have case 2. And we also have total. So, like for case 1 we have 3, then we skip 1, then we have 1, we skip, we take this one, and so on. For the second case we take this, we take 5, 1, 1, and so on. Let's see what will be here in total. So here the maximum value we can get is 3, right? Here the maximum value is 5, right? Here the maximum value is 4, which is 3 plus 1, because we cannot take this one. So at this point it is 4, and that means that our initial strategy from here was not very successful, because robbing a previous house would give us more profit than robbing the next one. So in this case we will consider this strategy as not successful, and we will assign the maximum value from the previous strategy. So the previous strategy gives us 5 here. Next, can we take this one? Yes, we can, from this strategy, and we will get 6 here. From here we can get even more. We skip it here, and we take this 5 from here and take this 3. 5, 6, 7, 8. So this 8 becomes from the combination of 5 and this 3, so these two houses, and so on. So this is a strategy. So here, for example, we have 1 and 6, which is from here, from this house, plus 1 equal to 7, which is less than 8. That means we should not take this one. And we will set 8 here. And we will continue our algorithm until we finish scanning the list. This solution is very simple, very straightforward. So let's do it, let's implement it. So I have to create two variables for two cases, and I will call them rope house case loot equal to 0, and I will create another one, skip house case loot equal to 0. Next I will scan our array for int I equal to 0, I less than nums length I plus plus. If I is even, then we will take this case. We will do this. We will calculate maximum value of the previous result for this case plus the value from current house from one side, and from another side we will take this value of another case. So we will add value to current case and compare it to another case. Else we will do right opposite. We will do it like this. And like that. That's it. In the end of the algorithm, we just need to pick which value is bigger. That's it. Let's check. Nums length e plus plus for int does not contain. Okay, yeah. Relatively new keyboard. Okay, so that works. Both cases are correct. Let's submit it. Yay! We done, and look at this. Our solution beats 94% of all submitted solutions here. And yeah, for some reason we use .NET, so I don't pay much attention on memory value here. So let's estimate our algorithm. So we need to have two variables here, and we scan this array once. So that means our solution has big of n complexity of time and big of 1 memory consumption. That's it. I hope you enjoyed the simplicity of the solution. This solution is a reminder for us to look carefully at the dataset before thinking about straightforward solution. In our case, the binary recursion would be a naive solution, and we could even try to improve it with memorization technique and dynamic programming. You should agree that the solution we have implemented is much more simple. Keep practicing and see you tomorrow.